So it says, when you move the decimal point, how can you know whether you are increasing or decreasing a number? So, um, let's see. Let's think about this. If I move it to the left, what happens? Well, yeah, but what does it increase or decrease? No, if you move it, it decreases. And what about if you move it to the right? Okay, that's a separate statement slash question. Maybe I'll provide some context, right? So let me give you an example. If I have 2.5, right? If I move that decimal to the right, it becomes 200, 2,000. We'll just say I move it a couple spaces. In other words, to get 2,500, I went 1, 2, 3. So I moved it to the right and it increased. But if I go 0.0025, that means I started here and I moved to the left and it's a decimal. So it decreases. Does that make sense? That's what they're trying to say. This is decreasing and this is increasing. Now, what you are saying is this would be a positive power of 10. I'm just going to put POS for that. And then this would be a negative power of 10, right? So I think that's what you were trying to say. Consequently, another thing that you could do that might be a nice reminder, if I think of a number line, right? When I go to the right, what is that? Isn't that the positive direction? And if I go to the left, isn't that the negative direction? So that could be like a little reminder. Question number 2 says, explain how 2 steps of moving the decimal and multiplying by a power of 10 leave the value of the original number unchanged. Well, so it says, explain how moving two, well, let me read this again. Explain how the 2 steps of moving the decimal and multiplying by the power of 10, the value of the number doesn't change. I'm going to reword the question. So what they're saying is if I have 2.5 times 10 to the 3, that's equal to 2, 5, right? So I got to move it over 3 spaces, right? I would go 1, 2, 3. They're saying, how come this 2.5 times 10 to the third power is the same as 2,500? Well, and then if it was a small number like our previous example, the textbook just says one direction increases, the other direction decreases. But you know what? I want this. This is an example. Okay, so go ahead and turn on your calculators. 2.5 times 10 raised to the third power. This shows that they're the same because 10 to the third power is 1. So what they want you to understand is that scientific notation represents another number. All right. So your scientific notation, this notation here represents this number here always. And it's not 2.5 by itself. It's 2.5 times 10 to the third power. Okay. And that always equals 2,500. And the textbook says, well, if you go in one direction, it increases. If you go in the other direction, it decreases, but it's the same value, is what they're trying to say. That question could have been worded